In this video, I will introduce how to use CoPre software to run in a 3D reconstruction. So for the first step, we need to check this project. This one is a project folder. We need the GPS information. This one is from base station, and here is from rover. And we need to check the image from IMG folder. That looks very good, pretty good. And then we can back to the software. So for the first step, we need to create a new project. From the home page, here is the create button. We just tap this create, and we can rename by yourself 3D model. Okay, and after that we can input our project data. The folder we can input from disk, from the local driver, and I have to say we need to choose this folder. Do not choose the folder higher than this one. Do not choose reconstruction. You need to choose the folder like this formal at the front, and we choose this folder and tap the OK. This one is a directory, is our output path. We can choose any path if we want to. We can find the result in this path. This one is the units. You can choose the meter, you can choose the feet, you can choose also the US river feet. Usually we choose the meter and create this project. In this interface, we have to define our project coordinate system. Because this project is connected in Europe from Hungary, so we need to choose this Hungary coordinate system. And this system coordinates system is HD72 and 2040. So we choose this coordinate system name, and we need to check these parameters in this coordinate system if it's correct. Because this project we need choose our some grid model. So for this GEO model, we need to choose this one, and the plane model we also choose CGD file and choose this HD22. So this one is depend your project requirements. You can choose your own parameters in this interface, and click OK and OK. So after that, we can see this project already be loaded in this projects load, and we click this one. So for the first step, we need to solve the pose. Pose means pose is the position of this AV photos or point cloud trajectory. So for the first step, we need to solve this pose. We just tap the pose solve and choose this project. Because this project we use the PPK mode. So from here we need to add our base station. We can add the other base station from any folders or any directories. Also you can put the base station in actual folders like this. LiDAR AA10 and base. And here you can see the base station already inputted in this base folder, so we don't need to choose from other folder. It will automatically be recognized at here, and choose this coordinate system type. We choose the local NEH, and everyone should pay attention to our base station information. I will show you this base station information in this folder. Here is a screenshot to show us this base station information. This one is the base station coordinate system name. This one is the coordinate under the trimple. We measure use the tab to measure this to measure the antenna height, and use the control points, or you can use the RTK to measure this base station coordinate under the trimple. So we can use this information to adjust this coordinate. So for first, this one is eastern coordinate, this one is the north coordinate, and here is our height elevation. Because in this project I already adjust last time, so I don't need change it again. If you are first input this coordinate into this settings in this coordinate system tools, you have to change this information to this true information, and we can see the measured height is also the same with this information, so we don't need to adjust this one. Just tap OK, and we can the software can start the post solve automatically. So once we finish this post solve, we can right click and display trajectory from this load. After that, we can see here is the trajectory is from our outside project, and here is a red line. Red line is a highlight. This part already be chosen by software automatically, so we don't need to adjust this highlight part. If we want to, you can see here, this one in this short night there is a red point. This one is haven't been highlighted, so because the altitude in this term, in this place, the altitude of the drone is very different, and it will be influence the results. If we don't want to process the whole of this region, we can right click and undo correct highlight section, and we can just, if we just want to process this part of this data, we can just click this from here to here and click here to here. So the software can only process the data at this project, at this section. We can also drag our mouse to choose the big region in the screen like this. click and drag the left button in your mouse to choose this section to process it. And here is calibration place. We can double click and click. Okay. After that, actually at here we can also display the true map. From here we choose the Google Maps. From this map we can check does this trajectory in a true place. You can see this trajectory is along this power line. So for this trajectory, it's on a true position. It also means we choose the correct coordinate system. It's not a wrong coordinate system. So from here, after that, we can right click. Before we actually we can also skip to this reconstruction section, this mode. And for the first step, before the AT it means area triangulation. So before the AT, we have to right click and choose this data solve. The next the last function the last step is post solve. So finish the post solve, we have to make the data solve. If we just want to reconstruction only by image, we can just we just click check this organize pictures. If we want to fusion the point clouds and pictures, we can also choose this point coordinate processing. So if we don't want the 3D reconstruction, we don't need to check this one, because this one is for demo for how to use the reconstruction. We have to choose the organize picture. In this, behind this, here is a written EXIF. This function can write the post information into pictures. So if we click this one, we can see the GPS information in the picture. In some third-party software like DJI Tarot, they need the software need the information from picture so that it can run in the data. So if you want to export this picture to a third part mapping software, you can check this one. If you just need processing in CoPre, you don't need to choose this one. And after we choose this function, actually this function is I already introduced in LiDAR processing, so I don't introduce this for more details. So after we choose this one, we choose this function, we just tap OK and waiting for the next processing. Once software finished those two steps, we can right click and display trajectory again. Display the trajectory. Actually, in this processing, note we can see here, we can click this. Here is the point cloud. If we choose this image pose at the left side, we can see here is the number of the photos, and we just click these photos. We can see the picture in the right side in the 3D view. In this step, after we finish the data solve, we have two here we have two options to proceed the next step. So for the first option, we can run in the AT. The AT means area triangulations. We can click this AT and choose our sense. Because this sense is from a plane terrain, so we can choose this plane for this sense. If this project is clicked from setting, we can choose this setting. Since is from the mountain area, we choose the mountain. This one is from plane, and the next option is we need to define the pose accuracy. I have to say this project is collected by PPK mode. So from the PPK mode is a very high accuracy. So we choose this. We here we choose a very high. We can define this plane accuracy to 5 centimeter and height accuracy also to 5 centimeter. If this project is from the third part zone, from this third part, camera brand, maybe the post is lower, is very low, is not the use RTK, is not use PPK mode. So maybe the post, the accuracy of the post is up to maybe 10 meters. So we have to adjust this accuracy to 10 or to 5 meters, because this accuracy I just say is very high after the PPK processing. So we can define this accuracy to a very high level. So for this option, we choose running the area triangulations. If we don't want to generate very high quality processing, we don't need running the AT function. We can just right click to skip the AT function, direct use the DOM function. This one can skip the AT workflow, but the results is not very good. Because we use AT function, it can run in the area triangle. This one can persist our picture position. It can calculate the every picture very high position after finish this running, after finish this operation. So if we want to get very high quality of the DOM or 3D model, we must run in the AT at here before we run in the DOM. When we finish the AT processing, we can right click we can click reconstruction and open this 80. Actually, I already run. I can remove this history 80 record, and here at reconstruction 80 node, we can right click and show this marked points. This points is calculated from 80 function, from 80 processing. And at here, if you want to improve your results, if you want to improve these results, you can import the GCP ground control points into software to adjust the results and improve the. Also, you can input the checkpoint to check the 80 results. We can back to the home page and open the GCP from here and input out a GCP or checkpoint. We can input this GCP. This one is a GCP file. For the GCP file, you have to use TXT or CSV Excel format. And to open this file, we need to define the every row, and for this file is divided by space. So we click space for this one. Space is a separator, and we need to define every row. This one is name. This one is and here we need to change this one to local NEH. And this one is eastern coordinates. This one is lost coordinates. This one is height, is elevation, and tap OK. And here we can see the GCP has been inputted into this interface. So if we just want to check the points, we can choose right click and choose this point type to checkpoint. Once we choose the checkpoint, these points do not adjust the results, just for check the how much errors from this 80 results. We can choose those points to checkpoint and make this point still refined point. Let's back to this 3D view. Actually, we can see some points already be input into this result. You can see here. Actually, in this project, we have only several points in this part, and maybe we can check the 122 here. Just a double click 122, and here actually this one is a mark center. At here this points is our coordinate. This green error is the coordinates is from our input. Actually this point is the center of this mark is actually coordinate, and this green error is the 80 results. So here you can see this one is a result, this one is the errors between this center to this error center. So if we want to check how much errors around here, we just click this just click this picture, and in this main view we can see the mark at here. And we need to press the keyboard control button, press the control button and click this point, and skip to the second picture and press the control click. So from here we can see we have selected two pictures, and this one is error. It's up to the 7 centimeter. We can choose a more picture from this interface. So this one we need to define. If we just want to check the how much errors from this, we can convert this point type to checkpoint, and after that we can export the GCP check and export a report to show you how much the errors from those points. And then we can skip to the 1 to 3 points, number 1 to 3, and then press Control to adjust this, to compare this different coordinate. In this part, in this number 1 to 4, these points, we need for like this GCP, we need to make sure which point is our true points. Maybe this point, maybe this point, maybe this or this. The better we take a picture after we finish the outside work, we can make sure which points is our true points. So for this picture, we assumed this point is near this point. We can assume this angle, this edge is the number where the number 1 for points is. So press and choose this point and choose this point. Press the Control and click. If we want to use number 1 to 4 to refine this result, we can choose it as a refine point. Press Control and choose this angle to adjust this point to its correct place. If you has choose several picture from this, you can click this GCP march. It will be automatically march the more points like this, such as I have choose the 4 picture from here. You can click GCP march. The software can automatically calculate the other points by itself. You can check every points to check whether it's at the correct place. For this picture, because this brightness is very high, so it's not easy to find the this mark. So once we choose those, once we choose the enough refine points, we can AT again. The second AT, we choose AT optimization. So during this AT workflow, the software can automatically adjust to adjust this adjust the results by those refined points to improve the accuracy of this AT. So now we need to wait the second AT at here. Okay, CoPre has been finished the second AT. Okay, let's show the market points again. And now we can click this 1, 2, 3 and check this checkpoint. You can see at this point already this green errors is very close to the center of this mark. We can also check this. You can see the points is very close to this point is very close to this angle. It's very close. It's almost the same point. This because we have run in the second AT. We can check other points, which the points in the project like the number 132. We can check the other points 132 at here. You can see the 123, the 132, the number 132. This points, it's a little errors here, but I think it's enough. If you think this points is not enough good, you can press the Control and move this point again. And then you can click GCP Merge, and you can see all of these points already are adjusted to here. And if you want to improve the higher results, you can AT thirst the thirst at front. Sorry, at the thirst. So this one is a AT to thirst. The thirst AT function. This one can improve the more higher the accuracy. After finish the thirst AT workflow, you can back to this checkpoint list. If you think the results still not good at all, you can continue to AT again, one by through this workflow. Back to this one, we can check the 162. 162, this point. It's very close. Yes. Okay, so if we think this result is enough for our DOM errors, our DOM requirements, we can back to the AT function at there, hit this, GCP interface, and back to this AT node, we can right click and tap the DOM. In this interface, we can see we can only choose the high quality because we already calculated by AT, so we must choose the high quality. This one can it takes a long time to output a good and high quality results. The second option is the DOM settings. We can choose our adaptive resolution. Adaptive resolution is the software can calculate this resolution by itself automatically. And if we want to define our own resolution, if we want to just export the 10 centimeter results in resolution, we can choose this value to 0.1 meters, so it can automatically export the 10 centimeter results. So if this result is 3 centimeter, so if we choose adaptive resolution, the results will generate the 3 centimeter result. And after that, we can tap OK to get the results. And it's back to this processing. From this processing, we have another option. For another option, if we want to more faster to generate the results, you can skip the AT. You can direct to the DOM. For this second option, we have we have two other options. For this big option, we have two small options. So if you want to generate the high efficiency, we can only use the image to generate the high efficiency. This one don't through the AT. This don't confusion with point clouds. It just can generate the high efficiency. This one we also choose these scenarios and click OK. This running is very fast because this one just very simple to combine the picture one by one. For this processing, it's without AT, without point clouds. It's just combine picture one by one. So this will process very fast, but the quality of these results is poor. If we want to faster to process the DOM results, we can also double click this. We can both choose this LiDAR and image. This is our LiDAR and image fusion technology. We can both check LiDAR and image and choose the high efficiency and choose the customer resolution and click OK. For this workflow is faster than pure image because this fusion with LiDAR and the image. In summary, if we want to create a DOM, we have the three options. For the first option, we can use AT, running the AT workflow, and after finish the AT, we can choose the DOM like this. After AT, we can choose DOM. We have to choose the high quality. For the second option, we can skip AT function direct to DOM. And here we have two options. One is only choose the image, pure image, just the image, and we can choose a high efficiency. And at here we choose different scenes, and we can define the resolution. And the third option is right click and direct DOM and choose the point cloud data, fusion with the image, and we have to choose the high efficiency and define other quality and click OK. So in summary, we have two ways to generate DOM. This is depend the requirements of your accuracy. And if we want to generate the if we want to create the 3D model, to start a 3D modeling, we have to start this from the AT node. It means we cannot direct generate the 3D without AT. So if we want to generate the 3D model, we have to choose the node from we choose from the AT function. So if we want to create the 3D model, we can start from the AT, this workflow, and just right click, and in here we can generate the model. For the 3D model, we have two options. This one is also we can confusion with LiDAR data, point clouds with and image. This technology is CHC specific technology. We can confusion with these two kind of results to generate or a 3D model. In this mode, we have two options can choose for the high efficiency and the high quality. And if we want to generate the 3D model only image, this one is for some oblique camera, because for oblique camera there is without the LiDAR sensor inside, so it's only the image. For this device, we can only choose image, and for the model, we can only choose the high quality. We can't adjust it to the high efficiency. Yeah. Only we choose the LiDAR, we can choose the high efficiency. Because this data is from AA10, if we want to save the time, if we want to accelerate the speed, we can choose the mix with LiDAR and the image, choose the high efficiency. And here we can select interest area. We can choose the all area. Also, we can choose select area. And if we haven't created DOM, we can also choose the output DOM at here and click OK.